In the last few problems, we've been given parabola equations and then we've been asked to find their characteristics. We're now given a different problem. We have been given a couple of characteristics about a parabola and we've been asked to find its equation. The question is, find the equation of a parabola with focus at 6, 0 and directrix x equals 0. Now, how do we tackle a problem like this? Let's first draw a diagram, okay? We know the directrix is x equals 0. So first, let's draw the y-axis, or the line x equals 0, which is the same thing. This is our directrix. The focus is at 6, 0. So let's just, for the sake of making it neat, let's say, that's 0, 0, the origin on the line x equals 0. And let's say this is our point, our focus, 6, 0. Now, what else do we know about parabolas that can help us solve this problem? We know that the directrix is always perpendicular to the axis, and we know that the focus always lies on the axis of the parabola. So, if the directrix is vertical, we know, number one, that the axis must be horizontal in order to be perpendicular to this directrix. We also know that the point 6, 0, which is the focus, must lie on that horizontal axis. Hence, we can deduce that the axis of the parabola is this line here, horizontal, perpendicular to this axis, to this directrix, and goes through the point 6, 0. Hence, we can tell that the axis of this parabola is the line y equals 0. The x-axis, essentially. Okay? Now, what else do we know about parabolas? We mentioned earlier that if the focus is a units in one direction of the vertex, then the directrix is that many units in the opposite direction. Okay? So, in this case, if this is the vertex and this is the directrix, we can deduce that the vertex of the parabola must be somewhere in between, equidistant from these 2 points, from the directrix at the point 0, 0 and from the focus at 6, 0, because it's got to be the same distance, the focus and directrix have to be the same distance either side of the vertex. What's midway between 0, 0 and 6, 0? Well, we know that it is 3, 0. So the vertex now is 3, 0. What's the value of a then? The constant that we referred to earlier. The constant a, as we mentioned, refers to the distance between the vertex and the focus, and obviously the distance between the vertex and the directrix. Hence, in this case, a is equal to 3, because the focus is 3 units that way, the directrix is 3 units in the opposite direction to the vertex. Now, the next step is, what does it look like graphically then? If this is the axis, if we know this is the axis, this is the focus, this is the vertex, this is the directrix, then the parabola must look like this. It must be a C-shaped parabola. So now, we've uncovered all this information. How now do we find the equation of this parabola? This requires a bit of recalling from GCSE and A-level. You'll remember the standard parabola has equation y squared equals 4ax, and it has vertex 0, 0. You can clearly see this parabola that in the problem is almost the same as the standard parabola, except that it's been moved 3 units to the right. The vertex is not 0, 0, it's 3, 0. But it hasn't been moved up or down, it's only been moved to the right by 3 units. Hence, this parabola is a simple translation of the standard parabola. And we know from GCSE and A-level that that means that if you were to write the equation of this parabola in relation to the standard, you would leave the y side unaffected. You would leave the y side unaffected because it hasn't been shifted up or down, is equal to 4a multiplied by x minus 3. We do this because we know that this parabola is very similar to this one. The equation must be of the form y squared equals for AX. It must be that way because they're both C-shaped parabolas. The only difference between them, as we've said, is that it's been moved 3 units to the right. And the way to move a graph 3 units to the right is to subtract 3 from the x coordinate, is to subtract 3 from the x variable in the equation. We know the value of a is 3. So let's simplify this further. That's going to be 12 multiplied by x minus 3, which is equal to 12x minus 36. And that's the equation of your parabola. Okay, so we took all the information we had, we drew a rough sketch of the parabola, and we were able to finally find the equation of the parabola by realizing that it was very similar to the standard one with only one slight shift to the right-hand side. Hence, we were able to modify the equation of the standard parabola, which we could use because of how similar they are, and we were able to introduce a simple alteration that moves this 3 units to the right. You'll remember from GCSE, if you subtract 3 from x in a context like this, it would move the graph 3 units to the right. And that's how we simplified it further, and hence managed to find the equation of the parabola. This is the final problem on parabolas. I will say this, that yet again, if you don't understand, please do practice, and secondly, it's no good just, again, watching me do this. You've actually got to be able to do this on your own. So please do write out the working as I'm doing it, and you'll actually come to realize that really helps you remember the concept and also helps you understand where you're going wrong and what you're not understanding. We're going to move on now to ellipses. Thank you for listening.